Hello, everyone. Hello. Welcome to California. I love this idea that now that you're in California and you've been here for a little bit, you are obligated to both do yoga and eat avocado toast. I don't know. Nobody did yoga. It sounded like avocado toast. Anyone? Maybe? Look at that. A ton of hands went up. That's fantastic. Yeah. Okay, that's good. Yeah, perfect. It is cool and strange to be back in person doing these sorts of things. I don't know if anybody else is kind of feeling that way. And it's weird seeing you all again, because I know a handful of you, but I almost don't recognize people without their Zoom backgrounds. That's been very strange. Also, don't know how many of you have been playing the game, but taller or shorter than you thought they were? Has anybody been playing that? I usually get I'm shorter than I thought he was. Yeah, that's usually mine. Which is fair. So hello to all of you in person. Hello to you on the stream, everyone that's watching live. Sorry you can't be here, but again, it's great that we have both options for folks who can't make it here in person for all sorts of reasons, so I'm glad we get to do all that. Big thanks to the Wild West Hackin Fest team for having me here today and for setting all this up and everything. This is, and I don't know if all of you share this opinion, but this is one of my favorite conferences, bar none. I find that this audience and the speakers that come to these and just how accessible everything is in Wild West Hack Fest. So hopefully you all feel that way as well. But I always recommend for folks who are especially starting out, Wild West Hackin Fest is great. So tell people who don't know about this place about this place. Cool. Let's go ahead and get started. Today, we're presenting on what is attack coverage anyway? The breadth and depth analysis with Atomic Red Team. It'll be fun. So, you all heard the spiel about me. I'm Adam Mashinchi. I'm the director of open source programs at Red Canary. So you can think of me as kind of the head of product for all the open source stuff, which is very fun. My background is in privacy, encryption, adversary, simulation, emulation. You can have fisticuffs over those two words and what they mean together later. It'll be fun. But my soul is a product manager under the hood. I do have a technical background. I know enough code to be dangerous. I write a little. I'm not good at it, but it's fine. Gets the job done. But really, with all my love of purple teaming and the kind of stuff that I want to promote, open source in particular, go Wild West Hackin Fest Toolshed, which is very neat. You should all check that out as well if you weren't planning on it. My big goal is to be an enabler. Right? I want to enable people to do whatever they should be doing. For example, if there's an open source program or project that has a maintainers team and they want to just be maintainers and not have to worry about all the crazy stuff or come to conferences and talk about their project and they just want to do maintainery things, great, I want to enable them to do that. If there are contributors to an open source program and they want to come do this sort of stuff, I want to enable them to do that. Those are all the things kind of wrapped up in my role. Okay. So let's get started. Apologies in advance. We are talking about MITRE ATT&CK. It's in the title. You all knew it was coming. But obligatory slide, yes, you're going to be hearing about MITRE ATT&CK probably 1 billion times in the next few days. So if this is the first time you're hearing about it, cool. We're going to have some explanation about that. And it's only a matter of time, as you all know, till every vendor on the planet is talking about MITRE ATT&CK to you, if you haven't heard that already. And then, the clock is ticking down for when your family brings it up at Thanksgiving, and that should be interesting too. So yes, we're talking about MITRE ATT&CK today. Sorry in advance, but it's going to be good. This talk is kind of an interesting one. For some of you who run the conference scene, this might sound a little familiar. This is actually the end of a trilogy of talks that all kind of had this similar title. The first one we did was one about coverage, this project when it was just getting kicked off, but it was really about a way to structure internships in cybersecurity for folks who are looking to spin up those kind of programs. And it was done under the lens of this project. And that was a lot of fun to be able to create a talk like that. It was called a two-topic talk. It was very tricky to create and have those threads interleaved, but it was fun. And again, thanks to Wild West Hackin Fest for letting me experiment in a talk in that way. We then gave a 15-minute update to this project at ATT&CK. My colleague Brian Donahue gave that talk. Brian lives very close to ATT&CK, and I live very far away from ATT&CK, so we just kind of obligated him. He did a great job. Thanks to Brian for doing that. And today, we're going to wrap up the trilogy, kind of. So it'll be fun. Some definitions before we move too far. For those of you who do not know what Atomic Red Team is, Atomic Red Team is this open source library of threat examples that are aligned to MITRE ATT&CK technique IDs. That's what it is. And one of the common misconceptions about Atomic Red Team is that it's software. It is not software. It's a library of examples. And I'm going to mention this a few times, but just keep that in mind as we talk about things. It's a library of examples that are aligned to MITRE ATT&CK. Now, MITRE ATT&CK, that thing is a matrix of adversary tactics and techniques and procedures. And it's a knowledge base of those things that have specific IDs. So for example, system time discovery is T1124 or something like that. And everything is aligned in that way. So for those of you who don't know what MITRE ATT&CK is, this is just the TLDR on that. A friend of mine, Jeff McJunkin, also calls MITRE ATT&CK a game of minesweeper for adversaries, which is an analogy that I love. You know, in this grid of adversarial things that an offensive individual could do, these are the kinds of mines that a given adversary might trip over as they try out different TTPs, if you will. And so they're also the idea that as a blue team, as a defender, you can design tripwires around certain adversary behaviors that you want to make sure that you can detect. And again, it's kind of just a cool lens by which to think about MITRE ATT&CK. So to visualize it a different way, again, on the left here, we have just a snapshot of the MITRE ATT&CK matrix. You know, under discovery, there's account discovery, and there's sub-techniques accordingly there. And then on the right, there's a bit of YAML. Regardless about how you feel about YAML, Atomic Red Team is aligned to YAML, with the goal being that we have this library of tests, YAML format, and it was, though created by Red Canary, the organization, it is maintained almost exclusively by the community. The community are the ones who add tests to it and maintain it. Of the maintainers team for the open source project, only one of them is a Red Canary staffer. And so, again, this is an entirely community-driven initiative to create this library and have it provide value. And it is mapped one for one with these MITRE ATT&CK IDs, which creates some odd scenarios. If you have an example for a given technique ID, but it also kind of applies to another one, well, where should it go? And the maintainers help assign those things, and sometimes you just duplicate it and put it in both places because that's where it should go. So anyway, just another view about what Atomic Red Team is. What's cool about Atomic Red Team, just by nature of it being an open source project, it has a lot of value to other organizations. So for example, if you are an organization designing emulation plans, well, those things can actually just be Atomic Red Team atomic tests under the hood. And that's what we've seen. So for example, MITRE's adversary emulation plans, those things are, if you look at them, a lot of them are just Atomic Red Team tests. Another one, Scythe's community threats. A lot of those tests that are developed, those come from Atomic Red Team, which is very, very cool. Red Canary's threat detection report, all the examples provided in that thing, Atomic Red Team tests. Now, I mentioned earlier Atomic Red Team is not software, but you need software to run the tests, all these examples, right? There's execution frameworks that do that. Many of them are open source, so Invoke Atomic, Atomic Test Harnesses, Atomic Operator, Caldera. If you've ever heard of these things, these are the software that run atomics and atomic tests, not Atomic Red Team itself. So it's just a really subtle distinction as you try to research this and get started with it. And then finally, commercial products also use Atomic Red Team. They've implemented this open source project into their frameworks, whether they be execution, defensive, or otherwise. So we mentioned Scythe, Prelude Operator is another one, Attack IQ. Lima Charlie also has some Atomic Red Team integration from a defensive perspective. Snap Attack, who did some speaking at ATT&CK, they also have this whole thing that uses Atomic Red Team. So you'll see this all over the place. But the goal of atomics, and of these atomic tests, this library of examples, in my mind, it's to solve the now what problem. And I think many of you who have to deal with, or get to deal with, threat intel profiles and the like, bump into this, right? You get a threat intelligence report. Neat. Thank you for describing this threat actor and the behaviors that they've done. Ooh, look, MITRE ATT&CK IDs. This is super useful. Cool, but there's no examples of the ways that the threat actor actually did it. What was the command that the threat actor actually used? I want to know that too, right? I want to build detections around that thing. And so to fill that gap, well, now that you've given me some vague information, now what? Atomic Red Team can answer that question for you. Because it has examples that you can utilize for the now what. If you see technique 1, 2, 3, 4, but you don't have any example about how to execute that or what it looks like or anything, the Atomic Red Team is here to help. So that's the goal. Atomics provide that actionable baseline for you to use this threat intel and actually build detections on it, or use it in your red teaming, as an example. So hopefully that makes sense. And of course, if you start to learn about these atomic tests, well, you can learn and grow. You could say, oh, that's a cool test, but I could modify that slightly to do something a little more interesting. Some last things. Atomic Red Team, the spec and the way that that project works, that library is added to, by design was to have the barrier to entry be low. We want strangers on the internet to add tests to Atomic Red Team. It is really important that people can do that quickly and easily. All of you could add tests to Atomic Red Team, whether you're adding a test or you're adding a typo or what, or fixing a typo, not adding a typo, please. Regardless, we want folks to be able to contribute to this. That's the goal. You shouldn't have to have 2 decades in threat intelligence to build that tests out for Atomic Red Team. We want that barrier to entry to be low. Consequently, there's some side effects to that decision, which we'll talk about in a bit, such as defining success and failure. It gets kind of weird, but again, we'll talk about that in a little bit. But again, Atomic Red Team, they're atomic tests, both like uppercase and lowercase a atomic. Test one thing. They're not an adversary emulation plan, not software. Okay, enough definitions. We're like, what, 15 minutes in and we haven't even got to the meat of this presentation. Problem number 1. What is coverage in the context of Atomic Red Team and MITRE ATT&CK? This is the coverage part of the talk. The first problem we encounter when we talk about coverage is, how do you define coverage? Kind of a weird question, but actually when you think about it, it gets a little complex as it turns out. So, the naive approach to coverage. Well, there's this grid of IDs. Do you have tests for each ID? If yes, that thing is covered. Win. Easy. Solved, right? That is breadth coverage, generally speaking. That's a simple one. There's X amount of tests. There's X amount of technique IDs. What are those numbers? Done. Cool. And then you can break that down by platform. And platform in the MITRE ATT&CK concept is kind of where you're doing the tests. So Windows, Mac, Linux, infrastructure as a service, containers, the like there. So you can break those things down. That's pretty easy. But what about depth? Depth coverage is a little trickier to define because it can mean all sorts of things depending on which way you want to slice it. How well does a group of tests cover a technique? Well, how do you quantify that? How do you conceptualize that? How do you automate that kind of question away? How difficult are tests to execute? Again, how do you figure that out? How do you do the maths to figure that out? And then what about a concept that Atomic Red Team has that MITRE ATT&CK does not? Sub-platforms. Well, infrastructure as a service is a platform in MITRE ATT&CK. Neat. But AWS and Azure are both infrastructure as a service, but the way you think about the techniques in those things is wildly different. And the examples you would provide for both of those things is entirely different. So we have to think about that sort of thing a little differently. So again, we had to conceptualize what coverage was. Now, oh yeah, there's no way you can read that. The galaxy brain text on this slide. I actually found what I had written there originally when I was generating this. And it's something along the lines of, let's see, so there's count techniques, breakdown by platform, and then the one is create a rubric for defining difficulty to execute a test based on a number of criteria, which can be duplicated by any human with said rubric or via script, preferably in Python, because Go is too hard to set up an environment in and to develop in. And really, who wants to use something like Ruby or Rust these days? Because it's probably just trendy, and I probably get made fun of if I try to write any code in them. Now, you wouldn't make jokes at me because you're all a really good audience, and I'm just saying it's reasonable concern, you know? Thank goodness I kept that text somewhere. I'd never be able to figure it out. Anyway, moving on. Problem number B. Okay, if we define coverage, who's going to actually help us fix the coverage problem that we might define? Yeah, that's a tricky one. And the way, and we alluded to this earlier, is you need to find resources to do that. But open source projects, a lot of folks who contribute to these things, it's not their full-time job. Right? It's my full-time job to care about open source stuff, but as per prior slides, I'm not a full-time developer. I don't know. It can write enough code to be dangerous. And asking project maintainers and contributors to help out, that's all well and good, but it's not their full-time job either, right? They already give a lot of time to these things. So who can help us with it? And really, just a brief aside, thank you to the maintainers and project contributors for everything you do. The project would be nothing without you, literally. So you're all the best. Thank you. And project maintainers and contributors are really good at small changes, like adding a test, fixing one thing. But this kind of broad, we want to evaluate coverage across the entire project. It's non-trivial to do. Quick shameless plug, if any of you contribute to Atomic Red Team, you get a free t-shirt. It's pretty cool. You should do that. AtomicRedTeam.io to learn more. Anyway, so the solution to who should help us coverage thing and solve it, the answer was interns, ultimately. It turns out you can say, hey, this is a really specific project that requires a lot of learning. This is probably perfect for an intern to assist with. Really quick, Internships 101. Again, we did a whole thing about this in the first version of this talk. But if you are considering hiring interns, rule number 1, pay your interns. Treat them like a part-time, full-time contractor, whatever. Pay your interns, okay? Rule number 1. Rule number 2, offer to work with the educational institutions if they are in an educational institution. Please do that. It's very important. Number 3, treat them like you would any other teammate. They are not there to wash cars because nobody else on the team's there to wash cars. They're like anybody else. Treat them that way. Rule number 4, pay your interns. Just do it. Just do it. Shouldn't be hard. Okay. And then do not, under any circumstances, hire interns to do menial, repetitive tasks. Occasionally, you'll bump into situations where it's like, hey, we need 3 months of data entry, right? Just people putting stuff in the spreadsheets or databases. Cool. Hire a data entry person, not an intern. Interns are there to learn from you and to get experience, so having them fill out spreadsheets all day, every day is probably not optimal. And finally, don't just use great company culture as a selling point. They're there to learn, not just hang out at the water cooler. That should not be the only selling point, which you've also solved if you listen to rules number 1 and 4 and you're paying them. Okay, so who helped us with this coverage thing that I've been talking about? This is Cameron, the intern, former intern at Red Canary, Cameron Roberts. Cameron's great. Cameron created all the prototypes for everything you're about to see. So thank you to Cameron for your hard work there. Cameron has worked at a bunch of cybersecurity firms, an awesome open source contributor, and likes hacking video games and playing video games. It was actually pretty cool. Anyway, if you bump into Cameron, ask about video game hacking. It's very, very neat. So thank you, Cameron. So this is the Atomic Red Team coverage project, kind of soup to nuts. Number 1, we did an analysis, or needed to analyze all of the tests and count them, basically, quantify them, but do that in a scripting way, and then a way to visualize that coverage, so it's quick and easy to understand. Part 2 was to categorize the tests we have. Again, that depth coverage, we need to do analysis there and generate that data. But first we had to define a means to do that. Number 3, after we did the gap analysis, we wanted to do gap analysis once we had that coverage visualized. We're kind of still there, which we'll talk about that here in a moment. And then talk about the future, which we're also going to do today. But this was the plan of execution. Part 1, count these things. Sounds pretty easy, right? The breadth analysis part. Do you have tests for that thing? If yes, that's a win. Neat. So Cameron, the first to go at this, we're going to do it in Python, and then we did it in JavaScript to visualize it. Pretty straightforward, seemingly. As it turns out, it wasn't straightforward. The initial goal was, hey, let's just make a giant spreadsheet of atomic tests and MITRE ATT&CK IDs and see what the delta is. But there's this weird misunderstanding we bumped into. Target platform was a field that created some unexpected problems. So again, in the MITRE ATT&CK context, a platform is where the adversary is doing the thing, like the target OS, if you will. However, in atomics tests, we'd kind of been wrapped around the axle a little bit in that target platform was where you might be executing the test, because historically, Atomic Red Team was based on endpoints. And so you think, well, I need to run Windows commands on a Windows box, platform's Windows, easy enough. But that gets really complicated when you start talking about cloud tests. Because say you're doing a test against AWS. Well, if you're doing a test against AWS, you're using an executor on a Mac or something to run that command. What is the target platform? Is it where you're running the command or the thing you're targeting? And as it turns out, this was misunderstood and miscategorized to a pretty substantial extent. So we had to figure this one out and define that platform really strictly in order to count these things effectively. So it was non-trivial. And again, Atomic Red Team has this concept of sub-platforms because GCP and Azure and AWS are all infrastructure as a service, but they're not all the same. The commands are different, right? So we had to figure all that out. However, with the good work, we were able to count those things very effectively and generate some cool stuff. Look how neat those charts and graphs are. We're really proud of these because these allow us a visual indicator of how good our test coverage is, how many tests for a given technique we have. It's all heat maps. People love heat maps, right? Right? Maybe? Okay, I'm seeing nods. That's close enough. Real quick, if any of you want to make charts and graphs, do not write your own graphing libraries, please. Just use Google Charts.js. Makes your life way easier. But here in these heat maps, you could see over on the right, oh, green means there's lots of tests for that technique ID. Red, not so many. White, there's none. Or over there, we see this bar chart. It looks like the MITRE ATT&CK matrix if you look at it. And it shows like how many tests we have covered at the tactic level. How neat, right? It's such a simple thing, but having these as visual indicators enabled us to have a quick, easy way. Oh, we're missing stuff there. We're missing stuff for that technique. We should probably, that's an easy tactic. Let's just do that. It gave us that visual indication, which is really, really important. Now to the tricky part. How do we categorize this stuff? That depth analysis. How well covered is a given technique ID? And we needed to find a practical sorting method. And again, it's just non-trivial at the face of it because, here on this left image here, well, if you have it covered, turn the color and then you're done. Okay, easy enough. But when we start to say, oh, well, what if this technique ID has 14 tests? That's good, that's covered, but only 2 of them are for Linux. Is that good? Is that good coverage, right? Or what if it has 14 tests, but some of them, or all of them, are really, really hard for someone to execute? Is that well covered? Oh, these are the kinds of questions that we had. And then to further complicate things, some of these technique IDs are inherently tricky to do. System time discovery is the easiest technique to test for in my mind. You type date into a command prompt and you're done. But then you think about things like network sniffing. Well, is that easy to execute? You need a network and you need some other applications, right? It's just non-trivial inherently. And then you talk about things like cloud storage object discovery. Well, now you have to sign up for a cloud provider and you need all this stuff and API keys to do that. Again, it's non-trivial inherently. So how do you count how well covered that thing is? The answer was this scoring rubric. This is what we came up with. And the goals of this were, 1, only use what's in the YAML. 2, define just some simple if logic around it to define a score, and then apply that to what we call a difficulty score. And then with that difficulty score, we can start to auto-apply stuff and check stuff and grade on a curve and all sorts of fun stuff there. So here's the example of the rubric. Again, just a simple one, but hey, could you copy and paste this thing? Would that work? If yes, nice. Low points. Does it have prerequisites? If so, high points, and so on and so forth. And this is how we defined our scale of difficulty that was entirely machine readable. The actual rubric is defined about prerequisites. Do you have to download a tool from the internet? Do you need elevation, privileges? Does it support the recent version of the platform or only run on Windows ME? That kind of thing. Does it require input arguments? Does the user need to interact with this thing? All these, does it use an application? Does the test executor and the prerequisite executor, do they match? If not, more points, that sort of thing. And does this thing require like manual interaction? Again, more points that way. So we defined this rubric, and what shook out of that was some pretty neat stuff. So now we had scripts and charts and graphs to define coverage, and we could see at a glance, oh, cool. Mac OS doesn't have enough tests over there. We should maybe go build tests over there. And then we had difficulty graphs of, oh, check that out. It turns out that technique ID is really, really hard to execute. How could we make that easier? And so this combination of breadth and depth coverage gave us a lot of ability to really analyze the project and its entirety in a way that those raw numbers kind of didn't really convey. And again, it was cool. It was all built up by an intern, right? It was someone who could learn everything about these frameworks, these open source projects, and get really deeply involved in understanding it. And so it wasn't just a menial task. It was, how do you create automation around this complex thing? So it's pretty neat. So we came up with ways to visualize that. And then once we had ways to visualize it, well, now we have to figure out how to fill those gaps. We've identified places that we're missing stuff. How do we make the project better for everybody? How do we make tests easier to use? How do we add more tests more quickly? And answer one of the biggest questions is, if any of you wanted to start helping with Atomic Red Team today, and you're like, well, where should I start? Which atomic test should I add first? I want to be able to answer that question quickly and easily, and not just like lick my finger and put it in the air and be like, I don't know, that one sounds good. I actually have a means to tell you where to start. That was the goal. So to meet that goal, we have kind of this idea of the heat map to end all heat maps. And right here, this is our difficulty heat map in a MITRE ATT&CK navigator layer here. And we could see quickly and easily, oh, the red or orangey ones, those ones are trickier tests to execute. The green ones are easier tests to execute. And again, the ones in white have no tests. Right here, it's super easy to figure out where you should start. Do one of the ones that have nothing, or maybe try to help out, if you know how, help out with one of the ones that is a little trickier to do. Cool, easy. Question answered visually, not with numbers and spreadsheets, right? That's the compelling bit to why we wanted to visualize all this stuff. But again, difficulty gaps. This is a non-trivial problem to figure out, because it seems like some techniques and some tactics are just harder. Right? They're just harder inherently to add tests to and to write tests for. Example, rootkit 1014. Like, how easy can you make designing a rootkit test? Like, can you turn that into a one-liner without any sort of prereqs or downloading anything or what have you? Like, that seems like it shouldn't be that easy. So maybe that one will always have to be difficult. Another one is data from a shared network drive. Well, inherently, you need a shared network drive, which adds complexity to that test. So again, it's non-trivial. And so maybe there's less value in trying to make rootkit tests easier immediately. And so defining that value became also a little tricky. And some techniques are just more critical for us as defenders to focus on because adversaries use them more, right? And so defining all this it's just hard to do, and it required a lot of homework when we were thinking about it. So looking at this, again, bringing back one of our difficulty heat maps here, defense evasion as an example. Defense evasion as a tactic is just more difficult to write tests for. We can see that visually here, quickly and easily. And I didn't have to comb through a bunch of stuff and make guesses. We just know that now based off the rubric we designed and all the automation we built around it. And so if that one is just more difficult, maybe there is less value in asking strangers to write tests for it immediately, whereas a bunch of other things clearly need some tests. Again, the whole point of this is to take something that is complex and growing organically and has new tests being built every moment, and to add some visibility for people who want to get started and to tell us where we need some support. Another way we could think about it is using this old product manager trick, an effort to value ratio. Right? If we took all of the stuff we could do, we could quickly and easily give it some scores of, oh, that tactic is trickier, so the effort's higher. But if there's no tests there, maybe the value is also high. And so we can define scores this way. Again, it's just like a ye olde product manager trick that we could utilize as we have all this coverage mapping to say, like, oh yeah, we actually need help in these places more than others. So filling these gaps, it's a work in progress, but we have lots of mechanisms now that we did not have before to help us achieve these goals. Which brings us to the future, which is kind of the call to action for today. One thing I'm going to talk about is atomic test bounties, and the other thing is detection and alerting coverage. So now that we've got all these maps and all this data, what do we do with it? Sorry in advance to all of us Hackfest if using this picture gets the stream DMCA takedown. Oh, hold on. No, actually, I can fix that really quick. There we go. Okay, cool. So let's say we wanted to make an atomic bounty program, right? I say, dear everyone, there's a test I want you to make, and I have really specific criteria for how I think the test should be created, or things that I want to have in that test. And the reward for this thing is variable because I actually have an idea of how difficult it might be to achieve this goal, right? Neat. Wouldn't it be neat if a corporate organization would sponsor the filling of this sort of bounty? It's not just you being a good community member and like wanting to commit to open source. It's you saying like, hey, I could get a gift card out of this. How cool is that? Well, lo and behold, Anti-Siphon Training, a John Strand corporation, actually has a bounty for atomics right now. It's going right now. I think it goes till, what, the 18th? And so you all can go find that thing and create atomics that are defined, and the ones that are great get stuff from Anti-Siphon. That's amazing, right? And this just happened independently because it's an open source project and the community loves to help out. And this is the sort of thing we want to do more and more and more of as more organizations have vested interest in this. If we flash back to earlier, remember there's all these for-profit companies that use Atomic Red Team under the hood and they just reap all the benefits from community work? Well, guess what? They want more free features in their stuff, and the community can provide them that. And so they can create a development cycle where it's like, hey, we'll give you stuff if you push stuff upstream to Atomic Red Team, and then everyone wins, right? The whole community is made better by this sort of project and these sorts of additions. So that's very cool. Now this is going to be this is a problematic slide. I apologize. I'm about to change the definition of coverage for everyone as we've been talking about it for 30 minutes. Detection coverage. This is the next place that Atomic Red Team probably needs to go. So imagine a world where you all have this library of cool adversary TTP examples, right? Well, wouldn't it be neat if you could automatically fire all of those things in your environment and see if you can detect them? How cool would that be? Like, you could just see automatically, like, oh yeah, we were alerting on all these things. And then we changed a rule. And could we fire them again? Oh, look, we're automatically detecting all these things, but we're missing that one. Like, how neat would that cadence be if anybody could do that? This is the holy grail. If we as a community can define a way that everybody can do this, there's much winning to be had. And there's been a lot of conversations about how you could achieve this at a community perspective. We've talked about Sigma, we've talked about Sysmon, we've talked about maybe new libraries, maybe adding to the Atomic Red Team specification. There's all sorts of ways we could achieve this goal. And the Atomic Red Team maintainers are open to ideas here, like definitely. So if anybody has thoughts on this, let them be heard. This is a community project. We can only all be better because of minds like yours. So there's no defined answer for this, even though we've started to see movement in this space. I mentioned Snap Attack earlier. At ATT&CK, they demoed a thing that was this, right? But again, that's a proprietary company. That's how they make their money. And so if the community can come up with a way to do this, that'd be pretty compelling. So again, the future, detection coverage, how could we figure this out together? However, there's a known problem, and I mentioned this earlier. We made a choice in building Atomic Red Team in the way it's designed to make it so that people can add tests quickly and easily, and you don't need to be a super expert and need to know every single little process that the thing might make or all the exit codes it might have or any of that stuff. You could just write a test and push it upstream. But because a given atomic test is just an example, and there's no concept of success and failure in the Atomic Red Team spec, well, if you're going to automatically run a bunch of these things and then determine your detections logic off of that, how do you know all those tests worked without looking at all of them individually? Like, how do you know that the thing you were trying to do actually happened and that you're not getting some sort of weird flag that you weren't expecting or an event log that isn't appropriate because the test didn't actually work in bulk? Because the Atomic Red Team spec doesn't have that concept of success and failure, this problem is very, very tricky. And again, we are open to ideas about how to achieve this huge library of detection coverage that you could apply automatically. And one example of like how tricky this can be, let's go again, my favorite example, system date or system time discovery, T1124. Again, the test for this is the word date in a command prompt and you push enter, right? That's the easiest you could get. But how do you determine that that was successful, that you ran that test successfully? Is it an exit code? Is it a value that it returns? What if you're not in the US and date formatting is differently? Like, how do you define success for that command every single time? And how does a person just create that? And what is the expectation around creating that test? Again, it's non-trivial to define these things, and we are open to suggestions. And we know that specifications need to grow over time. We know that these projects need to adapt. But this problem, this is the holy grail that I challenge you all to try to answer for the community. Because we're working on it, and it's tricky. So where do we go from here? We've talked about a lot of stuff, right? I've talked about charts and graphs and information and Atomic Red Team and MITRE ATT&CK. If you want to just dive into this, if you want to explore Atomic Red Team atomics, if you want to learn about this kind of testing, if you want to contribute stuff or join a Slack channel for this community, any of this stuff, where do you go? Well, you could go here. atomicredteam.io. We just launched a cool new version of this site, and it has all the integrated charts and graphs and stuff. We're adding atomics all the time. There's a bunch of new features and functionality, and it's much more rich of a resource for people who don't want to just like carve through a GitHub blob of YAML. That's the goal of what we've done. And to show, does it work? Is my animation working? Look at that. So let's say you want to search for LSAS tests. So look, you just type in LSAS and everything just pops up and it happens in real time. And you don't have to search GitHub for stuff because search isn't great. Not great. So solve that problem a little bit. So this is one of the things that you can do now. If you want to search for an atomic test, you just put it in a search bar and bang, you're right there. All the information available to you. Huge shout out to Jose Hernandez, one of the Atomic Red Team maintainers, for building all this functionality out. Again, I know enough code to be dangerous, but Jose really drove this functionality home. So that's all there, atomicredteam.io. You can search all the atomic tests right now, which is very, very cool. Another one, again, all this great work Cameron Roberts did. We have all these cool charts and graphs. Look at this thing. You change it, and animation happens. It's very cool. So we're pretty proud of this. But again, it provides you all that at-a-glance visibility of coverage that you just have. And you can download Attack Navigator layers and just throw those into the Attack Navigator UI, and boom, it's done. Also, if you have not played with MITRE ATT&CK Navigator and you do stuff with MITRE ATT&CK, go check out the Attack Navigator. Seriously, it's very, 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 very cool. And it's very useful when you're defining a way to visually map this stuff. Because it can be a little arcane as you're talking about technique IDs, especially to people who have no idea what this stuff is. So that's all cool and exists now, and you should check out Navigator if you haven't done so before. So, takeaways. If you've just been like playing Fortnite on your phone throughout this whole talk, these are the things you need to know. Number one, pay your interns. Just do it. If you take nothing else away from the talk, please do that. Next up, in Atomic Red Team land, atomic test gap analysis is underway. We've done some very, very cool stuff there. It's now visible to all. So if you want to get started with this, it's all available to you. We launched a new site. We got new tests being created by the community, like you all, every day, which is very, very cool. We have more information on what an atomic bounty program might look like. Again, thanks to Anti-Siphon for making one already, but more bounty stuff and knowledge about there coming soon, TM. Also, you should contribute to Atomic Red Team. It is very, very easy. I mean it. It is really easy. And don't just take my word for it. Take George Orchia's. Just tweeted this the other day. Literally like a one-line test and added to Atomic Red Team. I think, what did he use? Drop the imposter syndrome was how he started the tweet. Anyone can be a contributor. So if you even have an inkling of thinking about it, please do so, because only together as a community can we make this library more rich and add to the value of this thing for everyone. Again, you get free stuff. You can just fix typos. It's great. Anything. We want anything. Any help at all would be fantastic. Also, we give shout outs to new and top contributors in the Atomic newsletter, which goes out every month. Get your GitHub name right there, like, hey, you're great. And everybody should know it. We have a Slack community, atomicredteam.io, it's all there. Cool. So we're done a little early, but if you want to know more, I said atomicredteam.io, it's the place. Thanks, everyone. Thanks, WWHF Hackin Fest, for having me. Thank you all for being great participants. Thank you all on the live stream. We're all done.
Adam, I want to thank Adam for coming to grace us with his presence and convincing us all to use the ATT&CK framework. This is another in the encouragement to become part of the community. That's what the message you're hearing here, lots of open source, lots of everybody pitching in. So don't forget to pitch in and go check out the workshops. Be sure and come back for the next talk that starts at 10 o'clock. And any questions from the audience? No? How about your handouts? Where can people get your handouts? Are you going to post them to the Discord?
Yeah, so if you want to talk to me or learn more about Red Canary or Atomic Red Team stuff, we're in the vendor area. Just look for the red bird. So you can come over there. We're giving away some free stuff too. As far as handouts and slides and all that stuff, I'll post those when I post those. I'm sorry in advance. It won't be in the next 20 minutes. I'm very ill prepared. Wi-Fi is problematic. It's a whole thing. But I will post these slides ASAP somewhere soon.
So for those on the live stream, stay tuned. This is just early the morning of the first day of the conference, and it will be a good day by the end of the day.
Perfect.
Evening and morning.
Yeah, it's going to be great. So stick around for the next talk, too.
Come back at 10 o'clock. If you need to take a break, buy a break, take care of yourselves. Don't pee in the chair. It's code of conduct. Yeah.